From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders of the 3D printing industry.
When you buy an additive machine, you don't just buy an additive machine, put it in your facility, and it starts, cranking out parts. You need to have someone who understands the material that's about to come in so that you can spec it out and order it. You need to have someone who understands design so they can get the parts, put them on the platform, slice the file, upload it to the machine. You need to have an operator for the machine.
That was Prue. Chris is a change agent and engineering leader. He's currently the applications development manager at United Performance Metals in Hamilton, Ohio. And Chris has over 11 years in the additive manufacturing industry and has experience in machine and process development across several OEM platforms. He also leads teams in the startup of Agile Project management practices, deliver collaboration and transparency. His passion for materials and research allows him to grow within several dynamic teams. Chris resides in Westchester, Ohio, and outside of the office enjoys the outdoors and growing hot peppers to turn into spicy powders or hot sauces to share with everyone who has a curiosity. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Hey, Chris, welcome to the show. Excited to have you on, and I think there's going to be a lot of discussion around your career and all the material stuff that you're working on. So want to just start with, like we do with everybody else, kind of where you're from, kind of where'd you grow up, kind of what got you on the path to where you are now in manufacturing.
Mike, obviously excited to be here too. I think we've talked for a number of months now, and so it's great to join this. So, I mean, not to go all the way back, but I will go all the way back. So, I mean, I grew up outside of Hartford, Connecticut, and spent my childhood there. And when I got ready to go to college, basically just kind of said I'd like to go somewhere that's not around here. So I ended up in my first foray into the Southeast at Clemson University, which surprisingly, I don't have any Clemson gear on today. Normally, if you see me at any of the additive shows, or if you've worked with me, you know that I wear a lot of orange and purple.
That's not Georgia red, is it?
No, this one today is Red Sox. So yeah, this is that's my other passion of growing up in New England. Is having the Red Sox break my heart year in, year out. So, except when they win here and there. But when I got to Clemson, I got involved into materials engineering and, just really heavy into ceramic and glass processing, which, say is a passion. A lot of people who don't understand ceramics, they'll just kind of say, well, it's just dirt. What's the problem here? It's like, metals are where it's at. You got to be in metals. So took that and, made a career out of basically ceramics for a while. So ceramic forming, spray drying, pressing, tool and die design, then ceramic to metal brazing. So basically trying to just, join dissimilar materials. And then later on got, basically brought on down at GE Power when I was in Greenville, South Carolina. So kind of moved around a little bit and ended up back in Greenville, South Carolina, not far from Clemson for a number of years. And within GE Power, got into a project that was working in castings, trying to look at, and there's the GE patent for it, but, the disposable core die. It's basically trying to come up with next generation designs for the internals for gas turbine blades. And so that was essentially then using additive as the vessel for that to be able to inject ceramic back into and create that pattern that could then be cast. That was really the first piece into it. After that, I got involved in a testing project where we needed to get a demonstrator rig quickly. And so I got turned on to, this small company in Cincinnati, Ohio that people knew about, Morris Technologies, where they had this revolutionary DMLS process at the time, or DMLM, or whatever we like to call it nowadays, powder bed fusion, and essentially got an intro into what they're doing and how they were able to do it, and quickly be able to, at the time, for us, just create some rapid prototypes, but then a foray into understanding how well you can use this tool to be able to design kind of the new features to be able to enhance products that are already there, but then also launch new products. So that ended up moving me to GE Aviation for a number of years. So worked much within the casting world there, looking at next generation designs, but then also, 3D printing technology within the SLA realm, within the wax printing realm, and just trying to understand the limitations of those machines and basically push them to their absolute limit. So one thing I think I've tried to say for the last 10 years is, as I've gotten in additive, I've tried to promote additive to its highest level. And I don't know what that is. It's a rather ambiguous term, but it's the idea of, I think it's a powerful tool. I think in the right hands and for those who know how to use it, they can benefit greatly from it. I don't think it's for everyone. In fact, I think it was at the AMUD conference this year. I believe Paul Gradle from NASA gave a very good presentation, but he started off with, if you don't need additive, don't use it. And it kind of stunned the whole room to sit there and go, wait, what? But you're here talking additive. So, and again, he's just trying to say the same thing. It's not for everyone. So if you need it, absolutely, it's a great tool. But if you don't need it, don't just try to force fit it into what you're doing.
Yeah, absolutely.
So,
one question I did have, before we go too much further. So a lot of folks that listen to this aren't necessarily materials engineers. So you want to just kind of give a little bit of what it's ceramics 101. Kind of, what do you mean when you say ceramics? People think of like clay pots and things like that. Like, how is it used in an industrial space, and kind of what's the benefit versus a metal or a plastic?
Oh, absolutely. So ceramics, it does start basically at the mining level. So, it's, it can be a mined product that's formed. And so you can have anything simple from a brick to a toilet up to, space shuttle, tiles that go on the space shuttle. The biggest piece of the ceramic, alumina ceramic is one of the hardest materials on Earth. It can also be very brittle, but basically also it doesn't conduct a lot of heat, and also it becomes an electrical insulator in many cases. So a lot of the applications that I've worked on have either been heat dissipation or electrical insulation. So you're creating, for example, aircraft thermocouples. So you have, two or multiple leads that are trying to read temperature, but basically that signal has to be passed through in a clean way. So there's a ceramic insulator to make sure that it doesn't short out onto a vessel, so that you get a clean signal to get the temperature reading. Now, ceramics go into, if you read about in the news, now they talk about silicon carbide composites, so now they're going to have basically lighter, stronger pieces that go into the aircraft. They're going to have better cooling features. You may even get to a point where you don't even have the need for internal cooling anymore, which is a complete disruption. Within what I've done, it's the study of understanding inputs versus outputs. So when you get a raw material, what is it? So how do you characterize it? How do you classify it? How does it fit within your process statistically? How is it going to work, in terms of all of your other preceding lots of material before it? How do you minimize the variation? So, it has a lot of common themes to, I think, almost anything that I've done. But it was entirely based in ceramics without a lot of metal background. So getting into metal additive later on, became a little bit of a challenge to understand that, but very similar understanding microstructures, grain boundaries. Within glass, there are no grain boundaries. It's an amorphous material. So, similarities, but differences as we see it.
And as you were making this transition, kind of, throughout your early career and kind of getting into metal additive, what were some of the kind of job roles that you were kind of tasked with? Were you like doing long-term R&D? Were you running machines? Were you doing design? What sort of things, like in the a day-to-day life, kind of early on when you were looking at metal
absolutely
AM?
Well, so a lot of my career has been spent process development, a little bit within design and SolidWorks, especially when I was doing the ceramic to metal sealing, but mostly all hardcore process. When I started GE, I actually came in though as a Six Sigma black belt, so problem solving process, if you'd like to say, but utilizing statistics and mathematics to be able to to solve complex issues. But most of it has been that cross between material and process. is what I've done. I've been able, though, basically to have the experience and the fortunate capacity to work with processes from their infancy, say in an R&D invention process, all the way through to full scale production. So one thing that I always feel is a strength is that I've had that exposure. I think a lot of folks have been very much at the invention stage and not at the production stage. And I've seen, kind of cradle to grave on some of these projects. So it's, I have a pretty good idea, when I'm going through something, what it should look like. Now, again, that vision is going to change along the way, time and time again, but it's good to have that kind of depth or width of experience, if you'd like to say, so that you kind of understand what it takes. Because I think a lot of people at the invention stage, they are very proud of their invention, but they don't understand why it just can't be, scaled up quickly, and so there's a lot of hurdles they have to overcome to be able to get a process to produce at a high capacity.
And when you're thinking about metal additive kind of over your career, and we'll kind of get back to your career story as well,
you're fine.
In from that standpoint of scaling it to manufacture, kind of what are some of the big hurdles that you faced early on, and you probably even still face today, and kind of moving a product or a process into manufacture, into production?
I mean, the biggest thing I always say, and everyone says it, is it depends. So, I mean, it's going to be a lot of times dependent on industry. I mean, obviously, I'd say aerospace and medical have some of the highest hurdles to getting a product, say qualified. As far as the interest in it is very high, though. So, I mean, there's still a lot of experimentation going on there. But really, I mean, it's just going to depend. Some people have some very hobby applications, for metal additive. And so they have smaller machines and they really have no barriers to entry whatsoever. I think it's just coming up with the design. I still go back to the design, DFAM. That's one of the biggest keys right now that needs to be put out there for folks, because I think a lot of people just need to understand what a metal machine can and can't do. And that's going to depend based on the type of machine, whether it's a DED, whether it's a powder bed, whether it's a large machine, a small machine, whether it's a binder jet machine. What are the limitations? And so how do you make that happen? But also it's understanding your product and your process, because I think a lot of times when we go to people, we tend to ask them, what's your biggest problem? And they say, well, I can't get these parts. Well, I mean, and they come to you with, say, just a standard part. I mean, I'll just, think of a cube. They're like, can you make some of these cubes? It's like, I can do that, but you're not, it's going to be more expensive, and really you're not going to get any benefit out of it. You're just going to pay more. But yes, I can get them to you faster. And so some cases faster is key. But I think when we start the education process now and unlock the benefits of design for additive, and we come up with the limits on these machines, we're going to really start to see it open up quickly, because it's going to be intuitive to people. I mean, that's what I think about as we talk about my story. I didn't come up, the additive manufacturing, by the time I got out of college, I don't even know if it was in its infancy yet. I mean, it was a thought, I'm sure. But now, I mean, the kids that are going through schools, I mean, I've got kids in middle school, and I mean, they've got additive machines, right there in the school. So they're getting this concept. The local library here has a maker space now. I think it's amazing. So they're getting to see it firsthand, what it can do. I mean, now, granted, they still just want to make toys with it. And well, let's face it, I know those of us in the industry have all made toys with it too. So I mean, it's going to happen. But, I think that's one of the biggest keys into this scale up piece, is understanding what you need it for and where it's going to take you. And then what your long-term business case for it is. Because as these machines keep getting bigger and bigger, obviously they get more expensive. And so your business case then becomes a little bit more complex. But again, if you're going to need it, invest in it. Make sure it's the right size for what you need.
And so let's continue on kind of with your career. I think we left off at GE, kind of in that
okay.
space. So let's continue on.
I mean, to kind of go with that, GE, I had roles in thermal spray coatings, which, we could call maybe the original additive, basically building, bonding two dissimilar materials on one another and basically trying to build them up. That really kind of became my education in metallography after that, from a, coating interface standpoint, but then also from understanding, the surface treatment of metal parts to understand how well they would accept the coating. Then again, some time into GE Additive, working with the binder jet team there. So again, working through a couple of generations of machines that they're looking to launch. And then, also great exposure to, their concept laser and RCAM platforms as well, which then got me over to AddUp, which basically here in Cincinnati is looking to launch their North American headquarters, and basically worked with that team over there, building out that facility from basically a blank floor space up to a facility that I believe they just had their kind of grand opening a couple months ago. So, I mean, they've got 6 powder bed machines and 2 DED machines under roof now. And, the capability to be able to do part qualifications and then be able to have, kind of like a customer showcase center. So, within that role and even within the GE Additive role, we had, kind of a leased space that we were looking to build up. So that's kind of been the focus. And again, that piece of let's take something from off the ground to full blown production, that's where I come in. That's where I really have the passion and the excitement to see.
And so let's talk about kind of the AddUp situation. So, I mean, for those who aren't familiar with that company, you want to just go a little bit more detail into kind of what sort of products do they sell, kind of what's their differentiating factor in the market?
So yes, AddUp is a joint venture in France between Michelin and Fives, which are two, obviously very well-known companies, large companies. Michelin basically going into, producing tire molds and, realizing that additive can help do that faster and with less cost and with greater iteration. So I believe it was I forget the history now, but yeah, it was like 2015, they formed AddUp and they started again, building their own powder bed fusion machine. So essentially with that, trying to enter the market space with a 2 laser machine. But the idea was, a little bit bigger build platform. And then also, the ability to develop, material parameter sets for them to be able to offer in the marketplace. The other piece of that is they acquired a DE company called Beam. So I think a lot of people know Beam, not Beam It, but Beam. And because if you've been to the trade shows, you've seen their bright green out there. But now I believe that's all merged under AddUp. So again, the Beam DED system, again, combined with a powder bed system, opening the idea of, looking at potential hybrid additive. I don't believe that's, a route that they're going yet, but I mean, it's just the idea of having it available and at least having 2 technologies under one roof to be able to complement each other. And, again, their ability now, they've sold very well over in Europe. And so to enter the North American space, the feeling was, to get a shop over here and get it up and running. And they've got a fantastic team over there right now that's doing that for them. And so they are, focused in a couple of different areas where they're trying to, obviously try to sell machines, but then last year launched their new 4 laser system that is a kind of a closed loop system. So you put the material in, it's completely inerted, and it just kind of continues through the whole process without having an operator having to be exposed to it.
And so we've had, at this point, I think we've talked to all the talked to Renishaw and people from SLM and EOS on the show. And I always like to ask kind of the question about there's this dynamic, especially with some of these pieces of equipment that, I mean, they're hundreds of thousands of dollars, if not kind of low millions of dollars. And there's this learning curve that most customers need to go through to get to a point where they feel comfortable making that investment. So in terms of how are companies like AddUp still thinking about kind of that education piece and the balance between, okay, we're just going to print parts for people, maybe that's enough, versus kind of getting them to a point where they're kind of supporting the business model, buying a system, right?
Well, I think that's the point. And so for the North American case, that's the whole point of it, is having a showcase center where you can bring in customers to have them view the machine, train them, have them understand the service aspects of it, obviously get them some demo parts to where they feel comfortable that the machine can produce what they need, but basically interface and have a direct line to the folks that are going to be working on your parts, versus sometimes now a more distributed network where you might have a machine here, but the application engineer is here. They're trying to put it all under one roof so that it's very simple. And then from a customer service standpoint, basically just having those be the same folks that you work with. So basically one centralized area to have that, and to kind of have that training.
Yep, for sure. And so, so you're wearing a number of hats at AddUp. Kind of what was the next step in the career?
So from AddUp, I went over to Beehive Industries, and so Beehive, another startup in the additive space. Obviously I had some former friends over there from GE as well that kind of started that up, and so again, very exciting. Looking at again, going back to that same piece, advancing additive to the next level. So what are the needs in the industry? Beehive went ahead and made some acquisitions to help kind of grow in the additive space, but then also, how do you look at customer needs within certain industries and help go in with that design for additive mindset and kind of show them why they need additive. So it's a little bit more on the education side, but then being able to get people comfortable with it. So I sometimes equate additive to, again, dipping your toes in the water. You're going to do that before you just kind of jump right on in. So, very good team over there, and, working on just advanced additive applications. Really trying to change the game. And so, within that, it's almost like a similar story. Small facility, building it out, adding machines, adding equipment, making sure, we trying to, attracting talent. That's another key at AddUp. I think I was employee number 5 at that site. And, by the time I left, there were over 20 folks. So, again, trying to find talent in this marketplace right now. It's there, but it's a very volatile marketplace also. So, a lot of times I've had folks that they're interested, they go through the interview, we love them, we send them an offer, hear from them for a week, and they're like, yeah, I just took another offer. It's like people are getting multiple offers in this case right now. So it's still an employee marketplace, which is kind of cool and advantageous. But again, with that line, I continue to evolve where it's like, I like the idea, and then my passion is around growing business, working to take something that is small and make it larger. And so hence now, I'm here week 1 at United Performance Metals in their additive division, but it's a 360 because it is now services focused versus just parts focused. But the mission here, again, is who can we be to our customers? And we have a wide base. The number one thing we do here is build plate manufacturing. So I think as all of the European machine manufacturers, sold their machines in the US, that's great. But now what do you do with these heavy build plates? Are you going to ship them all overseas? You're going to wait for them in customs, or, can you find a place that's going to be able to make the build plates for you, economically, and then be able to ship it domestically? So we kind of become a US source for that. On top of that, though, looking at how else can we add value. So we got into build plate refurbishment, wire EDM, inspection. We're looking at expanding out, potentially into, to heat treatment, part finishing. Right now we're looking at the idea of, holistically, can we do build plate inventory management for people? So, not only can we make the build plate, we'll serialize it. We'll make sure that we know how many times it's been refurbished, keep all the quality metrics on it. So it's looking at how can we kind of fit in where, you have part producers, you have machine producers. What are the things, though, that maybe aren't their expertise that they need someone to come in and do for them and partner with them? And that's an exciting place. So, this is, maybe about 1.5 years old now, and it's going to continue to grow. And it's, again, backed by United Performance Metals, is a very large company, part of O'Neill Industries. So, a lot of knowledge within the metals, working industry. And so the availability of the metals out there, really makes it a perfect fit and a complement to that business.
Yeah, I mean, that's a really interesting model. I've actually been thinking about that a lot over the last few weeks in terms of certainly on the post-processing side and all these ancillary kind of pieces of the especially metal process that are involved. So, I mean, you probably know Craig Beaumier. We had him on a couple of weeks ago and talking about hipping and this whole aspect of it's not done once it comes out of the printer. And so many companies have this kind of decision point if they're like, it's one thing to go buy a printer, but then you may have to look at furnaces and hipping and depending on the application. So, I mean, from where you're sitting now, kind of how are you seeing that? Are most people thinking about, okay, we want to bring all of this, in some cases, pretty expensive equipment for post-processing and heat treatment in-house, or are they still looking, or are they looking to have someone outsource that and do it for them? Like, what's that balance that you kind of see in the market these days?
So in my opinion, it's a mixed bag, because it depends. And I say that again, but right now, I mean, a lot of your smaller companies that, again, as you alluded to earlier, when you buy an additive machine, you don't just buy an additive machine, put it in your facility, and it starts, cranking out parts. You need to have someone who understands the material that's about to come in so that you can spec it out and order it. You need to have someone who understands design so they can get the parts, put them on the platform, slice the file, upload it to the machine. You need to have an operator for the machine. So again, in that case, as a small company, when you've gone ahead and made that investment, you then have to ask yourself, at this volume, do I want to turn around and have a machinist, or someone who can operate the wire EDM, someone who can operate a mill, or do I need to just find a source that can help me with that until I get to a point where, I can make a business case for it? And that's the real key. So I think some of your larger folks, I mean, obviously, yeah, they're going to bring that in-house because it's about turn time. It's about cost, it's about controlling your own destiny. But I think for, the smaller folks right now, that's where I think we fit in. But there are a lot of other companies that are also procuring additive parts that, still don't want to go through kind of all the mess of it. So, I mean, again, that's where we come in to be able to help them, because we have a lot of those contacts. We can help steer them where they need to go. So, I mean, that's, as I say, it's not a definitive answer, but it really is. It's all about the business case. And so, I mean, if you can, our point becomes, hey, we've made the investment. We have wire EDMs, we have mills, we have grinders, and we have the folks in-house with that expertise already. If you don't, and, you need help, that's where we come in. And then also, I think we're willing to listen to folks too, to say, what else do you need help with? Is it going to be powder management? Is it going to be heat treatment? Is it going to be, not necessarily scrap metal, but I mean, again, with United Performance being such a large metal supplier, what can we do with scrap metal to be able to just kind of help that? Because at some point, I mean, there's a large ecosystem problem with this now, with all this metal going through. I mean, granted, there are a lot of great companies out there now too, taking in metal, refurbishing it, making it into usable powder. I mean, it's a green, sustainable way. So, how can we help be a part of that as well?
And I've been asking people this the last few episodes, but like, what's your definition of big versus small in terms of a 3D printing operator? I think of, like, for me, kind of like 1 to 2 machines, kind of the production metals machines. That's I kind of term small. Once you get 3 or 4 or above, that's kind of where I think it scales a little bit differently.
Yeah, I mean, I guess I would put it in terms of, I don't even know if I'd say number of machines, but just utilization. So, I mean, if you're utilizing your machine, say, 80 to 90% of the time, and even if you have one machine, I mean, you're going to go through a lot of build plates. You're going to go through powder changeover. You're going to go through consumables. Versus if you have one small machine and I'm not picking on tooling shops, but if you're just doing one little machine in a tooling shop for prototypes, you're not going to have that, you're not going to have that need yet for that. I mean, you could classify it in volume of business. You could classify it in, number of machines. I mean, obviously there are just gigantic factories right now full of machines. I mean, in fact, here in the Cincinnati area, there are several. They're very exciting to see. And, I read more about every day, new ones coming online. And I mean, now really you've got a lot of the space companies now heavily investing in machines. So it's, like I say, it's an amazing time to be in this industry and work with innovative companies like that and work with them on, what they can do. Because I think, again, a lot of the innovative companies have said, look, we thrive on innovation, we thrive on design. We don't want to handle build plates. So that's where I think it becomes the advantage is they say, look, we don't need to hire anyone to do this. We know you guys know what you're doing, so just go do it.
And so what's involved in that process of kind of working with the company on the build plate side of things? I mean, are you kind of send them on demand kind of supply? Are you refurbishing? Are you doing all the above? Like you talked a little bit about kind of qualification and traceability. I mean, what's involved in that in maybe a little bit more detail for those who are kind of getting that start on additive and in the metal space?
Well, so I mean, again, and it goes back to, like you said, complexity of industry or qualification. So, I mean, the idea of having a build plate, you're going to want to serialize it. You're going to want to know when it came in new, how flat was it? What was the surface finish on it? What was the true position of the, however if you're bolting it or sliding it into the machine or, however you're attaching it within the unit. You want to know where it started, and then obviously you're gonna build on it, and then you need to be able to, stress relieve it, cut a part off, and then you got to know what condition it's in after that, because you want to restore it, because you'd like to be able to reuse this investment as many times as possible. So you have to understand, has it warped? Has it developed any type of surface finish defect? Is one of your holes out of alignment? Are the slots in it worn? Depending on which machine manufacturer you are. So, I mean, where we come in on that, is obviously we can, build the build plate up from, the bare metal to, the print that's requested, be able to then go ahead and serialize that. And then again, with our inspection equipment, basically record all that quality data so that, every time you send it back to us, you have a measurement, you have a good life cycle on that plate itself, so that you understand if there are any issues in their process. Could it be attributable to the build plate? Don't know, but you'll at least have the data to be able to go find that quickly and simply. Yeah, so that's for us, like I say, we'll build it new, or we'll refurbish it. If we didn't build it, we'll still take it and refurbish it.
And it's so interesting to hear that part in terms of all the different quality steps are involved in. It's certainly production, right? You've got the metal powder that's going into it, all your process controls, your hipping, heat treating, and you have to think about the build plate. So are companies getting smarter about kind of thinking about the level of detail of build plates and serializing all of that information as the market matures a little bit and different industries are starting to adopt it more?
I think so. I think as you get into production, and or full blown production, you are seeing the need for that. I think as the aerospace industry especially has qualified more and more parts across multiple engines and across multiple engine manufacturers now, they see the need for that traceability, because if there is ever an issue, you need to have that complete traceability. And I think they've realized that the build plate, although it is kind of it's kind of a tool, but it's an important tool because it can have an effect on, the start of your build, or an effect on your parts. So it's coming around, but again, I think there's still the folks that have kind of crossed the chasm and are there in additive. And I think there are those that are still kind of waiting at the edge, kind of wondering, where it's going to go and if it's going to be right for them. So that's what still makes it, an exciting time to engage folks on all walks of life. Those that have been through it, done it, are very mature at it, and those that are still, trying to find their way in it. So with that key, I mean, it's also, helping them understand the importance of the process itself. And I think people are understanding that now. And it goes back to what I said with buying a machine. now do you need to buy, do you want to go buy a vacuum furnace? Do you need an air furnace? Do you want a hip furnace on your site? I mean, that's a huge investment. But, again, what's your expertise, and, how much do you need it, and how much are you willing to pay for it? So that's where I think people, again, have to make that decision. I think there've been a lot of presentations, at a couple of conferences I've been at now, talking about that additive supply chain and being smarter about it. So that's where we're trying to insert ourselves into those pieces of the supply chain that aren't necessarily the part design, the functionality, or the delivery of parts, but more so those ancillary pieces that, people maybe haven't thought about, where we can kind of jump in with some expertise and be of assistance.
And so you've mentioned Cincinnati quite a few times in terms of kind of being a major hub for Skyline chili, but also additive, it seems. So you also had the visit from President Biden a few months back. So you want to talk a little bit more about kind of the ecosystem around Cincinnati, what's kind of going on there, and some of the exciting stuff coming down the pike?
Well, I mean, absolutely. So, I mean, I think within, when you look within Cincinnati, there's a lot of it here. And I mean, I started earlier. I mean, Morris Technologies, one of the first metal 3D printers really in the US. That was right here. And then that got acquired by, GE Aviation, which turned that into GE Additive. And that's also, that's got a large presence here in Cincinnati. Then you've got AddUp that also, basically is within this area. Cincinnati Incorporated, going a little non-metal for a moment, but Cincinnati Incorporating, building their, BAM and WAM printers. I mean, that's all here. The also offset of that, then you have some of the service areas. Actually, to the north of here, you have Tangible Solutions. I mean, huge in medical. I mean, doing a lot of medical. So within that, and the presence of a GE Aviation, and also just a large presence of traditional machining in this area, it really kind of became a little bit of a headquarters. And then, like say, and then also Beehive is here in Cincinnati as well. So, there's a reason these companies are tending to gravitate to this area, and it's just due to the availability of the resources. And I think, some of the maturity of the workforce that's here. So I think in maybe some parts of the country still, if you talk about 3D printing, they may not know what you're saying. But I think as folks have been around now, and they've been to, say 2 or 3 different places, they start to know, and they start to see it. And so, I mean, it's been amazing for me and for my family to kind of, keep a career kind of local. I mean, I know years ago when I said to my kids, I said, "What's important to you?" And they said, "We don't want to move." I said, "Okay, well, that may not always be the case, but we'll figure it out." So, for me, this area, like I say, it's just a hotbed of activity. So it's very exciting to stay a part of it, but also now engage in a more global aspect, through what I'm doing here at UPM.
Fantastic. And so, kind of last question. So as you reflect on your career a little bit over in metal additive, and kind of over the last several kind of years, I mean, what piece of advice do you give folks that are just starting out or thinking about kind of moving into the additive space? Is this something that's going to be around for a number of years? Should they move to Cincinnati? Kind of what are their what are some of the tips that you think are important to instill on kind of that next generation of people coming into the space?
I mean, I think it starts with education, and asking questions. And I think it's, understanding your need for it, why you need it, but then also finding the right educational platform to further your journey. I mean, so to that piece around here, University of Cincinnati has a fantastic additive lab. Ohio State, again, a lot going on up there with their labs as well. So, I mean, again, even the state of Ohio, America Makes is headquartered in Youngstown, Ohio. So, I mean, again, we've got that piece here. That's why I think, that's why I think the president came here, to Cincinnati area, because, like say, it's a hotbed of activity, and looking at the, collaborative agreement, in terms of trying to bring more manufacturing back to America. This became a good area. Now, no, I wouldn't say to everyone move to Cincinnati. There are many places you can go in this country and really learn about additive manufacturing. But I think it's, ask questions and just, kind of look before you leap, make sure you understand what you're doing. Don't just hit the go button on the printer and expect it to be perfect the first time. Someone I've worked with, they had basically just like the build, the failure bin or the build of shame, or whatever. And other places I've been, we've given out a trophy of just this failed build, it's just like, okay, you get it today because here's the next one. So don't be discouraged, and, again, continue to learn. And there are a lot of great resources. I mean, a lot of great resources out there. So, utilize them. I mean, make sure it's the right thing for you.
For sure. And so, I mean, and coming up, I mean, the last part of the year, there's a lot of big conferences and trade shows. Will UPM be at any of those coming up?
Yeah, actually. So yeah, UPM kind of on the additive side just did their first, additive show up at Rapid that I think went really well. There was a contingent that just went over to the Farnborough Air Show. So again, very, one of the largest air shows. And then, yeah, we are going to be at the IMTS show up in Chicago. So I think as that's transitioned over the years, a lot more additive coming into that, say more traditional, tooling type conference. So there's a lot of folks that'll be up there for that this year. And then first time ever, we're going to go and we're going to exhibit at Formnext. I mean, so Formnext being like the, 10 Costco's worth of additive. I mean, all focused on additive. I went a few years ago for the first time, and I mean, it was just huge. I could not believe that they could put that much in one place. So always excited to go back there.
Well, fantastic. And I'll see you around the industry, and thanks so much for joining the show today.
All right. Thank you, Mike. You have a good day.